Welcome to the Explainer. We're breaking down the status definition from a high-performance gameplay system.
The secret? A radical approach to data that avoids all the usual performance bottlenecks.
This system is built for speed. It uses a special bytecode virtual machine, not the traditional methods.
Okay, so it's built in layers. We're diving right into layer 1, the data, where performance begins.
Here's where we find the most important piece, an immutable, compiled asset called the status definition.
So what is it? Think of it like a pre-compiled blueprint for any status effect in the game.
This blueprint follows 4 key design principles, all aimed at one thing: maximizing runtime performance.
And here's the most critical rule. This blueprint is immutable. It never changes during gameplay.
So what's actually inside this blueprint? First, you have the bytecode, the instructions for the VM.
Second, it holds all the constant data, like numbers and tags, in these really compact, fast pools.
And third, it lays out a table for any variables that the status effect will need to track.
The blueprint also defines the rules for things like stacking. So what happens when you reapply an effect? The rules are explicit. You can aggregate stacks, refresh the duration, override the old one, or just reject it.
By baking these policies into the data, the behavior is always predictable, with no extra runtime logic.
Okay, so that's the blueprint. Now let's see how it becomes a live, active effect in the game.
And here's the most important concept. The immutable definition is a template for a mutable runtime instance.
And crucially, these live instances are only created when they're absolutely necessary, like for a timed effect.
So the process is simple. The data is compiled, the VM executes it, and then creates a live instance.
This strict separation of data from state is really the secret sauce. It's what makes the system so fast.
So the number one takeaway is to respect this contract. The blueprint is read-only. All changes live in the instance. Which leaves us with a final thought. How could this blueprint-first idea improve the systems you build?